Welcome to another session of Everyday Mathematics. Today we are still on the MIT Integration B qualifying exams 2010, and our focus will be on these two problems today, and that is problem number 6 and problem number 7. So let's look at them. Problem number 6, which is the indefinite integral of 1 over 1 plus 3 e to the power x. Problem number 7, which is a definite integral from x equals to pi over 4 to x equals to pi over 3 of 1 over sine x to the power 3 and cosine x to the power 5. So these are very, very interesting problems. I hope you do enjoy following along. Problem number 6, which we said was indefinite integral of 1 over 1 plus 3 e to the power x. What we can do is we can divide the numerator by e to the power x, e to the power x, e to the power x, right, like that. And what that results in is this integral of e to the power negative x over e to the power negative x plus 3. And this clearly is very easy to see that the numerator is simply the negative of the derivative of the denominator. And we know that the derivative of natural log of x, let's say fx, sorry, is the same as fx over fx, right? So that when you integrate the left-hand side, it is the same as the integral of so log of fx would be equal to this. And so what we can do here, we can quickly see that our integral is the negative of natural logarithm of e to the power x plus 3, and obviously plus the integration constant here. And that is the answer. That was actually a very simple problem. And let's now jump to problem number 7. So on to problem number 7, which is the definite integral from x equals to pi over 4 to x equals to pi over 3 of 1 over sine to x to the power 3 cosine x to the power 5. Now notice sine x to the power 3 is not equal to sine x cubed, and also cosine x to the power 5 is not equal to cosine x to the power 5. Rather, this is the same as sine x to the power 3 is the same as sine cube x, and cosine x to the power 5 is the same as cosine 5 to the power 5x. So what we can do here now is we can say let y equals to sine x such that dy dx equals to cosine x, and so we could substitute for x cosine x dx with dy. And so we can now go ahead to readjust our problem by multiplying both the numerator and denominator with cosine x, so that now we do have 1 over sine x to the power 3x times cosine x to the power 6x cosine x dx. We did this because we wanted this part to be similar to dy here, right? And so another thing we would want to do is now change the limits when x equals to pi over 4. Y is the same as root 2 over 2 or 1 over root 2, however we want to say it. And then when x equals to pi over 3, that is the same as root 3 over 2 or square root of 3 over 2. And so now we can replace the limits with lower limit root 2 over 2, upper limit root 3 over 2 over sine x is the same as y, so y to the power 3, and cosine x is the same as a square root of 1 minus sine squared x, so it's 1 minus y squared over 6, to the power 6. And so applying this power 6 here, this becomes now 1 over y to the power 3 times 1 minus y squared all to the power 3. So that is our integral. And now the next problem is now how do we use partial fractions to express this in a format that now can be integrated. So this is where things really begin to be so dicey. And so if you have your cup of tea or coffee or a snack, just get hold of it. So this happens to be our integral as we got it in the previous frame. So the next thing is we would like to get this integrand, right? And then use partial fractions to express it in a way that we can easily integrate. So 1 over y cubed times 1 minus over 1 y cubed over 1 minus y squared to the power 3. It's the same as I could pull the cube 3 out, the power 3 out is equivalent to 1 over y times 1 over 1 minus y squared all to the power 3. Next thing now is I can go ahead and decompose this. This 1 over y times 1 over y 1 minus y squared is the same as y over 1 minus y squared plus 1 over y. And then now if you cube this, we can use the Pascal's triangle. If you look at the binomial expression, these are the constants that one could use. So this is one item, the power 0, the power 1, and then to the power 2, and there's the power 3. So the power 3, we have these binomial coefficients. So 1 here, this to the power 3, so it's y cubed over 1 minus y squared to the power 3. And then next we have the coefficient 3, so 3 times y over 1 minus y squared, and then 1 over y to the squared. And then the next one is 3y over y minus 1 minus y squared, or the power 2 times 1 minus 1 over y plus 1 over y, this part here, to the power 3. And so we've decided to color code it because we're going to, again, simplify each expression. So beginning with the blue item here, right? So what do we do there? So y cubed over 1 minus y squared to the power 3. This can be decomposed into y over, so 1 minus y squared is the same as 1 minus y times 1 plus y. So all that to the power 3 because we pulled the 3 out. Again, you use binomial expansion and using this same Pascal constant. So we pull 1 over 2 to the power 3 is 1 over 8, and now 1 over 1 minus y cubed for the first part with the first coefficient, and then the next one is 3 times 3 over 1 minus y squared times 1 plus y plus 3 over 1 minus y times 1 plus y squared minus 1 over 1 plus y cube. So that is that. Then we can now proceed and simplify this further. So we've pulled 1/8 out, and then we have 1 over 1 minus y cubed, and then 3 over 8, and then we decide to pull 1 minus y out here, so that now we have a combination of 1 minus y times 1 plus y. And then because we want to again use partial fraction here to make this a little bit simpler, and the same thing we did here, right? And then this one obviously is just minus 1 over 8, 1 minus 1 over 1 plus y cube. So simplifying that further, we have used partial fraction here. So this 1 over 1 minus y plus 1 plus y is the same as this and the same as this. So this here, now when you multiply 1 minus y in here, we get 1 minus y squared, and here we have 1 plus y times 1 minus y, the same thing we've done here, and then minus 1 over 8, 1 over 1 plus y cube. So again, we're going to break this into partial fractions. So we have 3 over 16 because this and this interacted, and then now we have 3 over 16 here, and we have 1 plus y squared minus 1 over 8, 1 over 1 plus y cube, because essentially what happens here is this one here and this one here can cancel out, and so the focus here is now we can put this here and this is here, and then we can bring a combination of this here, and that's what we put here, and this here is what comes here, right? And obviously this one here is what came here. Now let's continue. Now that we have finally gotten what this blue expression is 1 over 8 over times 1 over 1 minus y cubed minus 3 over 16 times 1 over 1 minus y squared plus 3 over 16 times 1 over 1 plus y squared minus 1 over 8 times 1 over 1 plus y cubed. So the green component, it's now more interesting because now, because it's 1 over y squared, 1 over y squared here, so we can cancel this with this, and so you're left with 3 over y times 1 minus y times 1 plus y. And then what we can do is we can go ahead and say, okay, if we have that, we can pull 3 over y out and half out, so that this part here becomes, obviously with the hidden one there, becomes this. And so when we multiply the y, 1 over y across, so we have 3 over 2, 1 over y times 1 minus y plus 1 over y times 1 plus y. Using partial fractions again, this part here becomes 1 over 1 minus y plus 1 over y, plus this part here becomes 1 over y minus 1 over 1 plus y. And so we can now collect this part and this part together, and that becomes 1 over 1 minus y minus 1 over 1 plus y plus 2 over y. So the green part is covered. Going to the purple part, which is just 3 over y, because this y here cancels with 1 y squared up here. So we have 3 times y over 1 minus y squared, which is 3 over y over 1 minus y times 1 plus y all squared. So we can pull out the 3y out, and then we use binomial expansion to the power 2 to expand this denominator. So that is easy. So we've expanded it, and then we can go further and multiply y across, so that now we have 3 over 4 out, and then now we can use partial fractions. Y over 1 minus y squared is the same as negative 1 over 1 minus y plus 1 over 1 minus y squared, and then this part here, 2y over 1 minus y times 1 plus y is the same as 1 over minus y, 1 over 1 minus y minus 1 over 1 plus y, and then this part here is the same as 1 over 1 plus y minus 1 over 1 plus y squared. Interesting, because we do have a similar things that we may want to deal away with. This one and this one can cancel out, and then this one and this one cancel out. So we're left with 3 over 4, 1 over 1 minus y squared. This part here comes here, and then this part comes here. So we have the purple part, 3 times y over 1 minus y squared, all squared, times 1 over y, being equal to 3/4 times 1 over 1 minus y squared minus 1 over 1 plus y squared. So in essence, what we have is the blue, green, purple, and orange components can all be bunched up together into what we have here. And then now when you sum everything together, we do have 1 over 8 over 1 over 1 minus y to the power 3 minus 1/8 over 1 plus y cubed plus 9 over 16 times 1 over 1 minus y squared minus 9 over 16 over 1 over 1 plus y squared plus 3 over 2 over 1 plus 1 over 1 minus y minus 3 over 2 times 1 over 1 plus y plus 3 over y plus 1 over y cubed. So plugging that into the integration, we get this long partial fraction and then integrating that, this first part here, since this is the same as 1 over 16 times 1 minus y to the power negative 2, this here becomes plus 1 over 16 times 1 plus y to the power negative 2. This here becomes 9 over 16 times 1 minus y to the power negative 1. This part here becomes this, 9 over 16 times 1 plus y to the power negative 1. This part here becomes this, negative 3 over 2 log 1 minus y. And this part here becomes minus 3 over 2 natural log 1 plus y. And this one here becomes 3 log y minus a half y to the power negative 2. And then we have our limits. So we substitute when y tends to negative root 3 over 2 or square root of 3 over 2. We plug everything in there, and we see these two parts here become something like this because we've now taken this constant out. And so we have 1 over 1 minus root 3 over 2 all squared plus 1 over 1 plus root 3 over 2 all squared. And then these two parts here, we've pulled the 9 over 16 out. 1 over 1 minus root 3 over 2 plus 1 over 1 plus root 3 over 2 minus log 1 minus root 3 over 2. And then because these guys have the same constant, this constant here, we can bunch them together, pull the negative out, and then just get the product of the two. So we have 1 minus root 3 over 2 times 1 plus root 3 over 2 plus 3 log 3 over 2 minus 1 over 2 times root 3 over 2 squared. Minus the limit as y tends to this lower limit, root 3 over 2. And the same thing, we repeat the same thing, we just, in place of root 3 over 2, we have root 2 over 2. That is straightforward, right? Then we continue so that now we can now pull these 2 out by multiplying 2 both the numerator and denominator, and then since we have a squared, that 2 going up squared is 4. Now we have 2 minus root 3 squared plus 4, 2 plus root 3 squared, and all that continues even with the lower limit. So pulling out the 4 out, and then also pulling the 2 out, we get 4 over 16, and since the common denominator becomes the product of this, and then we're summing these 2 together, and then since 9 times 2 is 18, we do the same thing, and also for the lower limit as well, right? So we have that, and now here, this is the same as 2 squared plus 2 times 2 root 3 plus root 3 squared plus 2 minus, so the minus and the positive here cancel, so that now we are left with twice 2 squared and then twice 3 square root of 3 squared. And then the denominator is just a square of the square of two numbers, the difference of the square of two numbers. So 2 squared minus 3 root 3 squared is 4 minus 3, which is 1. And the same thing we repeat down here. Same thing here. The difference of 2 squared, that is 4 squared minus root 3 squared, so which is 4 minus 3, which is 1. And then again, this part here and this part cancel, so we just have 2 times 2 here. And then obviously 18 over 16 is the same as 9 over 8. And then here again, we have the same thing, 4 minus 3, which is 1, and then we keep the denominator as 4. And we repeat the same thing for the lower limit, only that here now instead of root 3, we have root 2. We continue simplifying that, so that we have 2 over 4, because now this is the same as 14, and then we pull 2 out, so we have 2 over 4 times 7 over 1. 9 over 8 here, times this is 4 over 1, minus 3 over 2 log 1 over 4, plus 3 log root 3 over 2, minus 2/3. And then on the lower limit, this part is 2 over 4, 6 over 4, because this is 2 squared minus 2. 2 squared minus 2 is the same as 2. 2 squared is 4. So, and then the same thing here. So what happens is that now we have 7 over 2, because this is by 2, 1, by 2, 2. And then again by 4, 1, by 4, 2. So we have 9 over 2 minus 3 over 2 log a quarter plus 3 log root 3 over 2 minus 2/3. And then here we have over 2. And then we have 6 over 8, 9 over 4 minus 3 over 2 log 2 over 4 plus 3 log 2 over 2 root 2 over 2 minus 1. So we can combine things together, and so we have getting a common denominator here, 8. 8 times 2 times 7 is 8 divided by 2 times 7, that is 28. 8 divided by 2 is 4. 4 times 9, 36. Minus this part here, 8 divided by 8 times 6 minus 6. 8 divided by 4, 2 times 8 minus 18. And so all this first part is scattered here. And then here we're trying to combine this and this, because we have negative, and negative here becomes a positive. And so we have 3 over 2 plus log 2 over 4 minus 3 over 2 here, 1 over 4. So it's the difference of logs is the same as the quotient, the division of whatever is under the log sign. So 2 over 4 over 1 minus 4. So this would cancel, so we're left with 2. And then same thing here, 3 over 2. 3 times log root 3 over 2 is it? And then we have a minus here, so it's 3 log this divided by this. And so we have 3 root 3 over 2 divided by root 2 over 2. So this cancel. Plus 1, since it's negative here and negative here, this becomes positive, so plus 1 minus this 2/3. So this becomes 40 over 8, and when you divide this becomes 5. And then since we need to divide this, so we're just left with 2, and we need to divide this so that we are root 3 over 2, root 2, and then we have a third. 1 minus 2 over 3 is a third. So this becomes 5 plus 3 log 2 from here, plus 3 log 3 over 2 to the power half. This root sign goes up, and we're soon going to take this side, and then we have to add these two together. So we have 5 3 over 2 log 2 plus 3 over 2 because we pull the half here, log 3 over 2. Now when we add this together, what do we get? We get 16 over 3, and then since we have a common constant here, and then we have a product of whatever is under, because it's addition, we have 2 times 3 over 2, which is 3. And this here, ladies and gentlemen, happens to be the answer for this problem. So thank you so much for hanging on with us, and it's been an absolute pleasure solving this problem. It's really long and windy. There's probably an alternative solution to this problem. If you have an alternative solution, please share it with us, but we do enjoy solving harder problems. This is part of the little we can share with you for now. Thank you. Until next time. Bye-bye.